Hello friends, in this video we will be learning about interpolation, different techniques of interpolation, and we'll understand what those various techniques mean. In this video we'll be learning especially about two methods. So what are we going to discuss? Let me show you a quick place to find about this, the written tutorial. Simply search for Geounity and go to this site geounity.versal.app, or it's okay with this logo, right? Go to the site and in this site go to tutorials, and in tutorials scroll down and find interpolation using IDW and Spline, because that's what we're going to do today. So this video will be based on this tutorial. Simply we'll get started. We'll be using IDW and Spline methods. Okay, open ArcMap. We'll be using ArcMap for this demonstration. In another video I'll be showing you how to do those things using ArcGIS Pro as well. Let's add our details. Okay, so we'll be using the earthquake data of Japan. Let's add boundary, earthquake, and monitoring stations. So this is the data of earthquake that happened in when was it? 2010. Yeah, it's that earthquake. Let's change the symbology to something more obvious. Okay, something like this for the epicenter. That's where the epicenter was. Also, since we're creating that only for the Japan, we would like to mask it. So let's go to geoprocessing and environments. Okay, click on environments under geoprocessing. Let's change our workspace, current workspace, to be japan.jdb. Let's select this and add. Also scratch workspace. Yeah, let's keep this as our workspace. Processing extent, it should be fine, but we would like to change a few things like raster analysis. Under raster analysis, let me expand this. Okay, cell size as below. How much are we setting the cell size? Let's see. Okay, we'll be using 5,000, right? 5,000, that's good. And mask, yes, this one is important. We will be using the boundary of Japan as our masks. If you don't select this as your mask, then the interpolation will cover the extent of the whole extent of the area. So make sure that's used, and everything else should be fine. You can always refer to that manual to make sure of the right settings. Now, since we have the monitoring stations, let's also explore the attribute table to understand what's written in there. We have intensity in various monitoring station. What was the intensity of earthquake felt during the earthquake of 2010 in Japan? We'll be using these values to plot, to interpolate the intensity of other places as well and visualize them. Let's get this done. Let's get started. In search, click the search button. If it does not appear here, then you can simply go here and click the search button. Then you'll have this panel. In search, we first want to interpolate using IDW technique. So search for IDW and click Spatial Analyst. Make sure it's Spatial Analyst and not 3D Analyst or just Statistical Analyst. Spatial Analyst. Click the tool. Then we have the IDW tool. Input features should be monitoring stations. Intensity, Z value is intensity, that's good. What do we want the output raster to be? Let's call it IDW Power 2, because we are going to interpolate using Power 2. And let's keep it variable as it is and click OK. Nice. So we have the interpolated value. Let's turn this off for now and keep our we can also turn off the boundary actually. Yeah. Now let's symbolize it. You can right click and go to properties to change the symbology, and instead of classified, let's use stretched. And what color ramp do we want? We want another color ramp. As you can see here, we don't see the names of those ramp, right? So if you right click here and turn off the graphic view, then you can see the names as well. For this purpose, we'll be using Spectrum Fulbright. Let's click that. And also invert the color so that we can see higher value has more red color. Click OK. So here we can visualize the right. Let's zoom to layer to see it even better. So that's the IDW interpolation using Power 2. What if we do the interpolation by Power 0.5? Let's explore that as well, right? IDW tool, monitoring station, intensity, everything is fine. Just change the power to 0.5, and we will be changing the name as well. IDW power 0.5. Make sure you don't have a point in there because that name will be invalid. Also, better not use spaces. Instead, you can use underscore while naming your raster. Everything's fine. Let's click OK, and let's close this. You can double click to view the properties as well. Symbology, let's do the same. Stretched, right click, remove graphic, and select Spectrum Fulbright. Then go to invert and OK. What difference do you see? You see, when you use Power 2, then it's more coarse, the surface is more coarse, but using 0.5, you see it's smooth, more smooth, but there is loss of data as well. When you use Power 2, then we see more detailed, better interpolation, but using 0.5 we see more smoother interpolation. So that's the difference. Let's also experiment something else, like what if we insert the maximum distance as well. Let's see how much maximum distance do we want. Limit the search radius, right? So we'll be using 50 kilometers, right? That's 50,000 meters, and we'll use 5 points. So number of points 5, maximum distance 50,000. So that's going to be the search radius. It will search minimum of 5 points within the distance of 50,000, and it will try to interpolate that. We'll be using power for 0.5. Good. Let's change the name to something like IDW 50K. Okay. Let's see the difference. Again, double click it and go to symbology, stretched, right click, remove graphic, select the spectrum Fulbright and invert it. Click OK. Now let's observe. What do we see? What's the difference between the 0.5 that's with variable radius, but here this is with the radius within 50,000 meters? It's more detailed, right? You can also compare this with the power 2 as well. So power 2 is always more detailed and coarse, but power 0.5 is smoother. So that's IDW. Now let's explore another interpolation technique. Let's use spline. These have different use cases. Make sure to click the spatial analyst spline. If the tools does not work for you sometimes, make sure you have an customized extensions. Make sure the spatial analyst extension is enabled. If not, then the spatial analyst extension tools won't work. So let's go to spline, and here we'll import the mounting stations again. Let's call it spline regularized 1, sorry 0.1, because we are going to use regularized and the weight is going to be 0.1. Let's run this tool and see. Okay, so that's the spline. Let's double click it and change the symbology to stretched. I'm sorry, let's turn the graphic view, spectrum Fulbright, invert. Okay, so we can see the interpolation using spline. I'll explain more after we do something. So spline interpolates a raster surface from points using a two-dimensional minimum curvature spline technique. It uses that minimum curvature technique. It results smooth surface passing exactly through the input points, right? If we use this one, but let's see. If you see spline, then it usually forms a curve that can go beyond the minimum and maximum value, as you can see here. But in IDW, it's always within the limit. Let's do spline by another spline type that's using tension method and change the weight to 1. Let's rename it spline. It's not regularized, but it's tension and weight is 1, right? The naming does not really matter, but to understand our output, to differentiate the output, we can just rename it that way. Stretched, right click it, move that in the Fulbright, invert. Okay, what difference do you see? See, there are some difference on there. Spline tensioned, it's less detailed, more generalized than spline regularized. What if we want to remove the negative value? I mean, what if we want to limit the value to maximum and to the minimum extent, right? We don't want our value to cross the lowest value, that's 1, right? How do we do that? We can correct that using raster calculator. Raster calculator. Let's search for that tool, and let's use the raster calculator spatial analyst, and we will be using a condition. How do we build a condition? And here you can see various formulas, right? So we need a conditional formula. It was right on top from the very first place. Okay, so we choose condition and we select spline tension 1. Let's correct that. So spline tension 1, double click it, and then it'll appear here. And then after the comma, spline tension 1, So let's form this mathematical expression. What does this condition do? This has some 3 parts. So first is a condition. If spline tension 1, if it is less than 1, let's fill that. I just wrote that from my keyboard, or you can use this as well. If spline tension 1, the value is less than 1, if the pixel value is less than 1, then what do we want to display? After the comma, right? 1. If it's less than 1, then display 1. Otherwise, what do we want to display? Put another comma. Otherwise, we want to display spline tension 1 as it is, right? So that's how the raster calculator works. It's simple. What do we want our output raster to be? Spline tension 1 corrected. Let's make it shorter because sometimes GIS does not allow a very long name. Spline tension 1 corrected, right? Let's run this. Completed. Now again, double click it, symbology stretched, let's rename it spectrum Fulbright invert. Okay, so this is spline tension 1, but it's corrected. And the value, the lowest value is 1. So that is how we can perform interpolation using IDW and Spline methods. To understand more details, refer to this website. I'll also put the link in the description. And there's also the expression here. I've just written spline tension 1 here, but you can also change that as I've demonstrated in the video. Okay, thank you everyone for watching the video. If you like the content, please mind subscribing and liking the video as well. See you next time.